Test. This is the voice of God. Thank you guys. Anyway. Hello guys, and welcome back to Not ARM. And today, I have terrible news for you all, and good news. Congratulations, you don't get to choose which news you get first. The last two streams from yesterday, they got demonetized, probably because we made that image of the guy into the background. I don't think YouTube likes when you take images of guys and make them into the background, but I think it's funny. So I mean, I don't know why they got demonetized. Anyway, I'm trying to pop out the chat, but instead I'm dragging everything around the screen. Fuck. I blame Nvidia. Pop out the chat. This is what FVWM3 life is like. The FVWM3 grind set, bro. Grind maxing. Wowies. Hello. Damn, people like this background though. They think this one's the best one. Fucking best desktop wallpaper. I'll show you guys what I've done. But I got some good news too. Besides everything else, I have the greatest news. I made a r/th3 fish the other day, which is pretty good, by the way. This is my cluster right here, with a great camera. I used the best camera for that. And then this guy's working on some kind of tablet. And then this is one of my friends who's working on oh wowie, he put Arch Linux on there. He also put Windows XP on it as well. Oh, I thought this was just fucking Arch Linux for a second. I was like, is that Arch Linux? What for XP? I thought XP was like the shitty one. The one that looks shitty. Anyway, they're all shitty. If it's a product, it's shitty. I don't know, it'd be cool to get my hands on a tablet. I think this is the best photo of the cluster though. This photo right here is the best one of the cluster. It's got a crispy vibe. Anyway, that's r/fish. If you all go check it out, let me know by posting a photo of your favorite computer or something. No, OpenMPI. Wowie. What about OpenClaw? I can technically bind to them. What if I made my own OpenClaw? Like, OpenClawed. OpenSoft Windows. Royalty free. But not open source. On Techity, it's gotta be open source. IWOCL 2026. Wowies. Unified Shared Virtual Memory System has been working on a follow-on to OpenCL 2.0 SVM. We would like your feedback. Unified memory is interesting. HIP is better than OpenCL if you're on AMD. Oh, you mean like the HSA stuff? Or HIP, which is like the C++ thing? But HIP. I don't know, I just want something more portable. It's a C++ thing. Heterogeneous compute interface. I don't know. There's just too many options with AMD. I don't really know. I don't really like GPUs either. Honestly, it's like too many options. Yeah, it's C++. It's for doing graphics processing. Well, I think you can use it for, not graphics. Jenkins file. As your DevOps. I think OpenCL is better for portability, though. I think I'd prefer something that's portable over something that's not portable, since I have a very many different options. I don't really want to have to like be like, yeah, I got to learn CUDA and HSA and this other thing and another thing, and then learn 25 things. I don't know. There should just be less of that. But OpenCL is pretty good. Yeah, that's what I'm saying. But it's slower. Yeah. So here's the specification. OpenCL API specification. C language specification. Spurv environment specification. That's it. I don't want to have to read a whole PDF, but we might have to do that. And we'd have to go through all this and make a new binding for it. Pretty sure the other binding, I haven't... Yeah, there's a lot of stuff here. I also don't want to turn on the GPU server every time I do this. Because then I have to turn it off and unplug it. And plug it back in. I gotta figure that out this weekend. Gotta rearrange my life. There's also OpenMPI, which is pretty interesting. That'd be something we're going to do on the cluster, though. I don't know. I really want to change it up today. We've been doing too much GPU stuff lately. This is for multiple computer setups, though. So if you have multiple computers, you can use OpenMPI to connect them all. And then... if you have that, there's also OpenMP, which is another thing. This thing is also for GPU stuff. Kind of. I need an explainer of this one, though. Get the specs. Holy shit, yes, give me the specs, please. I'm putting it in my documentation. You better damn well be sure I'm saving this to my documentation folder. Ha ha ha. I kind of want to do assembly. Oh, my bad. Oops. Is there an open... I think I already have the OpenMPI one as well. Message passing interface. I don't know what OpenMP is. It might also be the same thing. just a different name, but same idea. Although OpenMPI is like the standard for that. But we could set this up on the cluster. All you have to do is compile it for the other thing. We might do that this weekend. I keep putting it off, but I don't know. I'm saving it for a special occasion to look into it. Also hate writing bindings because there's just so much to write. I'll show you guys what I got with Raylib. Like, I got pretty far in that. I don't know. I was thinking about doing some OpenCL though. That's what I was kind of thinking about. Or maybe learning some more Haskell or something like that. Fortran. Fortran, pretty interesting. So, main.d. And then, been making some progress on this, but not really much. Shut up, Jester.
There are undoubtedly a lot of very intelligent people writing Java, better programmers than I will ever be. I just wish I knew why. Steve Holden.
Because they write spaghetti code.
Chester. One C++ 33 and one C++ programmers prefer Java mode. Because much trans plus Mackie Nephew SMA.
If you have any C++ roasts, let me know. I'll put them into Jester. This is as far as I got on that. I don't know what its problem is. Maybe it's because I'm running Arch and I need to specify that it needs 4.6. Also, on the ARM one, pretty interesting as well. Compiling it against literally everything. See if I compile it against that, it works either way. But then nothing. No output. It's supposed to put text and a box. But looking at the info, everything succeeded. So, I don't know what's wrong with that. Maybe it's using the wrong GPU backend. Because it is using the Intel built-in integrated graphics. So I don't know what's wrong with that. Because this code is correct for sure, 100%. It is correct code. Anyway. Oh. Let's see what's, I don't know. I don't really know what I want to do. Because this isn't working. I guess we should try to troubleshoot it. Maybe I could pass a flag to get the correct GPU running that? Not the Intel R UHD graphics that are built into the computer. Device initialized successfully. It goes through this process and then does all the GL stuff. Then it continues. Render batch vertex buffers loaded successfully in RAM and in VRAM. Default font loaded successfully. Working directory. Time per frame 16.66 milliseconds. Default shader unloaded and default texture unloaded. Window closed successfully. So that's when I close the window. So I do /main. And we look at it again. Target time per frame. Pretty much everything up to here is working. But nothing renders. Which is pretty interesting. I don't really know what to do with that information, so I'm gonna just browse the internet until I find what I think could be the answer. Raylib, no worky. It's an issue in this GitHub post. Windows, Ubuntu, OpenGL, Intel HD 550. Plus one friend also had the same issue under Windows. Rendered twice. I don't even have anything render. Looks like C++. No, it's written in C. In main, yeah, it's written in C. Wait, do you have to return? Don't you have to return 0 in C? Clear background, blank, draw text. Clear background. So he does clear background and makes it blank. I wonder if we just remove clear background in general, will it do anything? I bet it's just doing it too fast. Oh, hey, there's a white dot. There's a tiny little dot on that portion of the screen. Try that out. No, that's just a crumb. Dust? Dust crumb? I don't know. That's weird. Yeah, no, that was just dust. That was just dust. Okay. I mean, I guess I could clear the background. I wonder what happens if I do this. Because it makes the colors. That's a start. Maybe it only draws one time. Alright, there we go. Alright, yeah, no, still nothing. It's probably something to do with a GL version. Raylib can't display fonts. Render texture not working for me. Also, could be that we don't even have a full binding. Which, I don't know. I don't really want to write a full binding for it. Anyway, that's enough Raylib for one day. Yeah, I don't know. Raylib, it's cool, but like, unless you're writing it in, writing with it in C, then, I guess, I don't know. How does it go? Hashtag include. Where is there hashtag include? Hashtag include raylib.h. that's done inside of those. Cool. I think you gotta do lib raylib though, don't you? Then we do void main. No, we can do int main. And then I'm gonna learn some C today, looks like. Learn some C lang. Wowers, guys, I'm writing some C lang today. Alright, so after calling int main, let's open up my dlang project and I'll just translate it back to C. Main.d. I don't need to define anything. I can literally just call it straight away. So we need to create a car or string. I think you have strings in C-lang. If not, then that's gonna really suck. But I don't really write C much, so let's see how well I can do writing C for a program. But it wants a const car pointer. Probably you should just pass a const car pointer and call it what it is, a const car pointer. And go down. Let's see. We already have those colors though, so we can skip that. Init window. This is the same. This part of it, which is something I really like about desyntaxing, needs to be changed. Well, so technically I can call this without those. While not window should close. And then set target FPS is 60. This is the same as well. Pretty much everything's the same. Except for like a few weird syntaxing things. Clear background. That's how the program knows it's finished. Return 0. Is there a shutdown for this? Close window. Alright, here we need to do the clear background, and it's gonna be, we'll just put, save as, I don't know, game.h. Alright, I think that should compile. So what we're going to do is we're going to take clang or GCC, one of those two. Clang, and then there should be game.h. And then, I'm not really familiar with them. libraylib.a.
36 Manchester 0 C++ 33 M. If C++ is the worst to be taken seriously, where does PHP fit in? Asking for a friend. 0 and 36 Manchester 0 C++ 33 M. Being really good at C C++ is like being really good at using rocks to sharpen sticks. Testament. 0 and 36 and
Nice.
Chester.
All right, let's see.
33 n. There are only two things wrong with C++. The initial concept
Error expected or identifier.
Bertrand Mayer. 0 and
I switched to Arch, by the way. Good job. Congratulations. Welcome to the Arch domain. Post your Arch experience on my Red Hat. It's pretty cool. Huh? I made a Red Hat, by the way. Since Red Hat is fun. Red Hat is the meme of all time, so I've made one. UTF-8 source file is not valid UTF-8. What do you mean it's not valid UTF-8? What the fuck? Yes, Arch is the best. I think Gen 2 or like Void are also pretty good, but I just like rolling edge distros.
M Chester. 0 C++ 33N. It has been discovered that C++ provides a remarkable facility for concealing the tribal details of a program, such as where its bugs are. David Cahill. 0 and 36 M Chester. 0 C++ 33N.
No, we need to pass a linker flag.
Is better than C++ is like arguing that grasshoppers taste better than tree bark.
Gen 2 is a religion? Yeah.
36 M Chester. C++ 33N.
Yeah, no, I'm not ready for C. C has me off guard, bro.
Facility for concealing the tribal details of a program, such as where its bugs are. David Cahill.
What if I just wrote C programs? What if I became a C programmer? A C map. We were doing VLang at one point. VLang's pretty cucuroni enough. Or I should write assembly. Write it in assembly. Assembly, by the way. I don't know. I don't like Raylib. I don't like any library. I like to write it all myself. But at the same time, I don't know everything. So sometimes it's fun to play around. We've been too much in the library grind set. So I know what's going on here. Because we're trying to take libraylib.a, it's trying to include from that. And it can't do that. Because libraylib.a is an A file. It's not a header. So we need to copy the H file into this directory. So that means I need to go to my other terminal instance and cd to download. Fuck. Oh, by the never mind, I shouldn't say that. Raylib master ls cd raylib cp raylib actually cd // src cp raylib .h to home / d _ lang game or nice. I'm quaking right now. Quake maxing. Sorry, I just got done playing Quake 1 for a little bit, and it's still in my brain cells. Game.h and libraylib.a tab to give me my H file. Raylib.h. Huh.
Arguing that Java is better than C++ is like arguing that grasshoppers taste better than tree bark. Testament. 0 and
Let's see if we need to pass the -L for x11. That should give us lib x11.
M Jester, 0 C++ 33N. C++ similar in Wolf's clothing. We are the Straustra. 0 N.
Simula in wolf's clothing? What the fuck is simula? What do you mean lib array lib.h not found? Fine.
36 M Jester, 0 C++ 33N. Why was the C++ programmer kicked out of school? He didn't know how to handle exceptions. Maggie nephew SMA. 0 N.
Raylib.h. Alright, we need to do that. It's not a library, it's a raylib.
36 M
Wowie.
Jester, 0 C++ 33N. Whenever the C++ language designers had two competing ideas as to how they should solve some problem, they said, okay, we'll do them both. So the language is tubero for my taste. Donald
Okay, we'll do them both. Yeah, I'm gonna do them both too. Passing int to parameter. Yeah, man. I think I'm gonna leave the C ecosystem today. I kind of got other ideas for my C programming adventures. I feel like we should go on a C programming adventure to become a C master, aka a pirate, or something. Note, passing. We'll just do it with GCC, by the way.
36 M Jester, 0
Fuck.
33N.
Oh, by the way, GCC and Clang handle things differently.
Steve Taylor.
I don't write C programs, I write D ones. But if I did this, I'd have to make it all better C compatible. I wonder if that's a good subset of D-Lang. Better C is like C++ minus. So it's just C plus. Why do we need two pluses? Why not C++ 2? When's that coming out? CX, C times, C minus. Or what about C divided? C squared. Damn, bro. I don't really want to do really. Let's find something better to do. I'm like out of projects lately. It's kind of like burnout, but like not really, because I kind of got to keep doing more, but like I don't know. I want to take a break from the HSA stuff, and then maybe C#'s got what we're looking for. I don't know. We need to do something. Need to do something. Raylib kind of oversimplifies things. I think that compared to like GL, where it's like it works, but it's not as portable as Raylib. But like I don't know. Like ideally in a perfect world, everything works everywhere, regardless of what's going on under the hood. But like the problem with that is that then it's either you include so many dependencies to account for the fact that anything could be potentially, you know, like stuff that you gotta fix. Let's look at C++ libraries. C++ standard library. Oh. Isn't what's it called? What about Musil? Libmusil. Musil backends. I want to go to OS Dev. There's questions I have right now. GCC cross compiling, UEFI, and Legos. I mean, I kind of understand that concept. Modes, virtual 8086 mode. Oh, right, like, technically, you could get your computer to be in, like, a 16-bit mode. Protected, real, and then the x86-64. So, like, the, I don't really know too much. I'm not gonna really try to go too much into details about it yet. Meaty skeleton. Wowie. We do a lot of linking, though. Maybe I should reverse engineer things. I don't know. Like, what do I want to do today? This is the question of all time. Should we reverse engineer things? Should we, like, put something together? Storage devices, ADAs, hard disks, serial system calls. This is how you call the system on ARM. The instruction SWI jumps to a predefined address, which in turn jumps to a system call handler. The system call handler executes the specific function and return the user code with move PCLR. Most of the time you won't need to worry about returning from the interrupt, as GCC setup the cross-compile for ARM lets you code the interrupt handlers in C. Void SWI handler, attribute, and interrupt, which is like some kind of intrinsic or preprocessor thing. I don't know. C, I don't know. Interrupt vector table. Properties, maybe. I don't know. What's the at? It depends on what subset of assembly this is. It could mean many things. If this is the GNU assembly or GAS, then it could be completely different for it. Which it probably is with ARM stuff. With ARM stuff, I remember I was using GAS for assembly. You've probably noticed that SWI takes an integer amount. To get this argument, we have to do this. This loads the high 8 bits, 16 to 24 the argument into vector. This loading is the full 24 bits won't work using thumb. Monolithic, different design considerations. Modular, exo, micro, monolithic. x86 system calls. Scheduling, stuff about like processes and threads. Message passing, so like inter-process concurrency. Like having two things run at once, then one sends a thing to another, and so on and so forth. Then these are more like the hardware side of stuff. So like if you have the hardware side of stuff. Non-x86 development, which ARM is probably one of the harder ones to get into. If you guys have seen any of my attempts to install Arch Linux on ARM, which go wrong most of the time, then yeah, ARM is very weird. GAS, FASM, MASM, YASM, and they all have a different syntax, but I bet you can probably target different architectures with those. LLVM assembler. So the LLVM assembler, which I probably have installed, is pretty interesting. I think that's a great point for a video. See, that's an LLVM assembler.
C++ 33 C++ is more of a go-type thing full of high voltages, large chain-driven gears, sharp edges, crushed. And because of its complexity, many if
Oh
not
my
most
god.
users don't know how
Oh
to
my god. This is gonna be a lot of gestures.
and to loosen arm.
Gestures Q is cued.
0 M 36 M gesture 0 C++ 33 M C++ is to C as lung cancer is to lung.
In LLVM projects, what am I gonna do?
36 M gesture 0 C++
Make a new
33
project.
M. C++ is the worst to be taken seriously. Where does PHP fit in? Asking for a friend. Mason Wheeler 0 M
LD. Which this isn't all of the stuff, but like I have a feeling that a lot of the stuff with these is like you don't really want to use LLVM for a lot of this. I don't think. LLVM has a very interesting thing, which is or based on how it works, it probably. Well, it doesn't probably do this. It does do this. It compiles it down into LLVM bytecode before doing the final step. So basically, everything you write in an LLVM compilation ends up the same. Just maybe slight differences in how it was compiled down to. But at the end of the day, it's all compiling down to the whatever the LLVM bytecode puts out, which I guess is C compatible. I'm not too sure about that. What I do know is that it all compiles to LLVM bytecode, which might not be the best when you're making a OS, because if you make an OS, it's probably not great. But this did give me an idea for today's episode, so I mean, and probably future episodes to take a break from like fucking writing 2 weeks of writing bindings. So there should be a documentation of LLVM assembly, which we can read. The LLVM assembly reference manual. Abstract. This document is a reference manual for the LLVM assembly language. LLVM is an SSA-based representation that provides type safety, low-level operations, flexibility, and capability of representing all high-level languages cleanly. It is the common code representation used throughout all phases of LLVM compilation strategy. The LLVM code representation is designed by to be used in 3 different forms: as an in-memory compiler intermediate representation, an on-disk bytecode, and as a human-readable assembly language. This allows LLVM to provide a powerful intermediate representation for efficient compiler transformations and analysis, while providing a natural means to debug and visualize the transformations. 3 different forms of LLVM are equivalent. So it doesn't matter if you have bytecode or IR or the assembly, they're all the same, pretty much, is what it sounds like. That's just the thing. I think that's what it means. This document describes a human-readable representation and notation. The LLVM representation aims to be lightweight and low-level while being expressive, typed, and extensible at the same time. It aims to be a universal IR of sorts by being at a low enough level that high-level ideas may be cleanly mapped to it, similar to how microprocessors are universal IRs, allowing many source languages to be mapped to them, like by an abstract tree syntax or whatever the fuck. By providing type information, LLVM can be used as a target or as the target of optimizations. For example, through pointer analysis, it could be proven that a C automatic variable is never accessed outside of a current function, allowing it to be promoted to a simple SSA value instead of a memory location. So here's what LLVM assembly looks like. Well-formedness. You got, I believe this is a register. And then you have add, then you have a type, int L. Which I've written some assembly. I'll admit I probably should write more assembly. But that's also another point to bring up. There's a tool in the LLVM kind of ecosystem. I don't know, I don't like the word ecosystem, but disassembler. And we've played around with disassemblers before. You can do a lot of fun stuff. But like really at the end of the day, reverse engineering things comes down to, or reverse engineering the code we write will be really interesting to do. But LLVM dis is a thing. So let's write some D code.
Has taught me one thing. It's this. Just because the system is consistent doesn't mean it's not the work of Satan. Add new Plotkin. 0 10.
Actually, let's write some better C compatible D code. Let's change it up. Core.standard CIO. Then there's standard isn't it standard C.standard DIO? That's it. And then extern C, and then void main for the entry point. Void Amin. Bro, we name it void Amin. This is crazy today. And for this, we're gonna selectively import printf. There we go. I'm writing some code today. Printf. We've done a lot of disassembly with like regular disassemblers, but what about LLVM disassembler? Will it translate it back to the bytecode and then into the thing? I don't know. This is something I've been thinking about playing with for a while. I just haven't gotten to it, but today is the day. And then we need to do this %s and then comma hello. We need a string. I think that's how you do that. Sure. Actually, let's include a variable. And we're going to call it string hello world, or I believe you need to do a car pointer. But that might be the Fortran in my brain. There's a little bit of Fortran in there that's kicking in. It's going, I need to have an exact number for the amount of letters I have. But let's just do a string and see what happens. I don't know, can we do a string into this? Also, it isn't C exactly. This isn't C. This is D-lang C. So it's a little bit different. Why am I putting it as a function? What am I doing? Hello words. We'll see what is exposed to equals hello world. What is that? Alias? Come on. We gotta get it down, bro. Hello world, exclamation point. I was cooking for a second. Where's my LLVM projects? LLVM projects. Save. Save this as hello.d. What are you programming, buddy? I'm just playing around right now. I don't have really any ideas. I'm just gonna write a simple better C hello world program, and then we're gonna disassemble it with LLVM disassembler. Just an experiment. I don't really have any ideas, and I just spent 2 weeks writing bindings, so I'm like kind of burned out, honestly. But LDC2 dash, let's go with optimization 3. And then let's do hello.d. So hello.d, and then go from there. Dash better C. No need to do any linking or anything, I think. I'm pretty sure this won't compile first try.
36 and gesture 0 C++ 33.
Can't pass dynamic arrays to.
C++ is like being really good at using rocks to sharpen sticks.
Must be a car pointer.
0.
Maybe that. I don't know, might want a car array. I kind of had this in my head, but deprecation, hello, specification %s must be a car pointer, not a string. Okay, then if we do /hello world, it will give us hello world. But that's because I forgot the new line, because we technically are writing C. We need the /n right there, and then recompile that. There we go. Now, llvm -dis. Let's try disassembling /. Is there a intermediate in there? Maybe the O file? That's an object file.
In Chester, 0 C++33N. C++ is the best
Hmm.
example of second.
I think we should be able to assemble or compile it down to an LLVM assembly. Let's try hello.
36 in Chester, 0 C++33N. Arguing that Java is
This is a manual for that.
is
We'll have that open.
that grasshoppers taste better than tree bark.
Now I can also do object dump.
0 N.
This is one of the most useful tools that I've ever learned. Object dump -o. Let's go with dash and capital D for disassemble, and we could disassemble hello into.
36 in Chester, 0 C++.
Oh, it's obj dump in it.
C++ programming doesn't take to change a light bulb. No, they just
Jester needs to shut up.
global variable. Magnet USNA.
Ah, one other thing. Oh, look, something with GNU EH frame header. Probably to do with technically it is better C. I don't know. Might have something to do with the C library, glibc. But yeah, it's a lot of stuff in there, isn't it? You'd think like for an assembly, for like basically a C program at this point, you'd think it'd have a lot less things in there. And I think a lot of that's just residual artifacts of like the garbage collector. So like what I could do is just what I forgot to do is add dash release. What this will do is it will absolutely prevent any garbage collector calls or anything. So then I can do obj dump, and we should have a lot less. .note ABI tag, CABI application binary interface tag, I guess. And if you do a -t, it gives you the symbols, and it says ELF format or ELF 64 x86-64. Goes through everything. I don't see. I think maybe there's mangling, but I don't really think there's any. And then there's -o. Or is it capital O? Never mind.
Maybe the guy who invented C++ doesn't know the difference between increment and excrement.
Yes, he doesn't know the difference between increment and excrements.
36 in Chester, 0 C++33N. Java, the best argument for small
So
fonts in C++.
next we could call
0 M.
next we could do ldc2-h. This will give us a list of different things we can do with it. So we should be able to turn it into bytecode or LLVM assembly without assembling it. Generate documentation, write a C++ header equivalent to standard out. I wonder why you would do that actually, that's pretty interesting. Extern D. So you can make it write C++ headers to things. Symlinks. I don't know. Well, I guess for like for the D name mangling, technically you can extern to C++ programs. I haven't really done that much. That's something that I'm kind of scared of because people told me it's pretty hard, and I'm gonna be honest, I kind of believe them. So but all you need is a nm, and you can dump out the names and stuff. Nm is just like the other thing. dash no disallow the use of the inline assembler. MD compute. Oh, do they include D compute now? I think they do. But no, I think you might still need that specific backend. But you can basically compile to compute with this to like a GPU compute by passing dash MD compute to the compiler, which is kind of interesting. It's got its own subset of rules. Dash fastmath for all functions. Include both IR dash FFAT dash LTO objects. Dash FLTO requires linker support. Merges all input into a single file. Parallel importing code gen faster than full. LLVM gold. Oh yeah, there's two linkers. There's LLD and LLVM gold, I think. They have the dash F no PLT. Let's see. LLVM compile to, let's see about figuring out LLVM to LLC. Let's see. I'm allergic to LBC, I think. Dash output LL. I don't know, maybe that's it. Let's see. Oh, this is the LDC file. I actually tried compiling LDC one time. Pacman-S LDC. Snap, void, XPPS. I think void's got some pretty good stuff on it. Compile it down to dash
36 M Chester, 0 C++ 33 M.
That's not it.
C++, it's possible to make code that isn't understandable by anyone. With C, this is very hard.
So dash output LL.
0 M.
So let's go ahead and look at that LL file that's there. And this is what it looks like in LLVM assembly representation. Source file name, hello.d. Target data layout. A bunch of stuff that if I read it, it would sound like comma, comma, colon, comma, comma, colon. Target triple, x86, 64, PC, Linux, GNU. So targeting this system. String private unnamed constant, which is 13 times 18. I don't know what that, or 13 times I8. Okay, so 13 letters long, which I think is what the first one means. And then another one, a string 1, which is getting put in front of that, I think. Keywords, I think. But I think when you call, this is all speculative, but I think when you call the printf, what it does is it goes, let's go ahead and try to put the, let's put the string and just append a 1 to it if it's in that same position, then put them together within the same line. So I think here we don't see, oh, we do see semicolons. Semicolons go in front of these to create the comments. I think this isn't really something you would want to use to write in. Unless this is the bytecode. No unwind UW table. LLVM ident. LDC version 1.42.0. Fascinating. And then again, more of the M triples. But really not much going on here, other than like some weird eyes, maybe register or some kind. A header. So then can we do LLVM dash this on hello.ll?
36 M gesture 0 C++ 33 M.
So what about
Relational compiler.
output dash?
Impenetrable errors. Unlockable cross-platform compat. Basically useless tools. Aaron Kugler.
Let's try LDC to dash help, and then pipe grep out. Output BC, so that's the bit code. That's IR, which is the intermediate representation. So that's what's in memory when we're compiling it. And then we also have the MLIR, which is, I don't know what that is. A modern LIR? I don't know. An O file, an assembly, so like output dash O for that. Single OBJ, create only a single output object file instead of like multiple, I guess. Output S. Let's try the compile command, but do a assembly file. ls. Now I have an assembly, hello.s. Let's go ahead and check out what that's got in it. That's the assembly. So this was the intermediate representation. This is what it looks like in memory, like when it's telling the compiler what to do and stuff. But then this also contains stuff that the compiler is going to use, and like kind of complicated. But I think this is a header, some kind. It says source file name. It's like kind of data stuff. Then you got some constants, which are going to be at compile time. All your constants that you define, they're going to be put into the program as what they are, because they're not going to change anyway. It's like, you know, you can define a variable constant and then be like, all right, here we go. And that's also another thing with like it's into metaprogramming, where like you could probably use constants and stuff like that with metaprogramming to like maybe change them if that's a possibility at compile time, to where like, you know, you got compile time stuff going on. But that'd be more metaprogramming. I don't think that'd be constants. That's something I don't really know too much about. I've done my share of templates, but that's about it as far as metaprogramming goes. And I don't think D really provides a lot of that yet. But let's open up that assembly file. Let's see what it looks like. So we got an assembly file. We got a dot file, hello D. This is also what the compiler sees. It's just another different representation of this. So it looks like it always defines the file that we're compiling. Then it goes and says section .text.main AX. Continues down. We have global main. P2 align is 4. Which I don't really know what that means yet, but probably something to do with aligning things. And then a main. So we have our main. So we have push Q to register AX, and then we have another one, CFI underscore def underscore CFA underscore offset 16. Then we have LEAQ. We have .l .string .1 register IP, and then register DI. I'm guessing this is L equals. I'm not sure. I'm not familiar with assembly. I see a pop and an XOR and a call, which means it's calling another function. Call printf. So a C calls a C function. Call printf, and then I'm guessing the @plt is to put the thingish in there. Thingish. That's pretty much it. .NOTE GNU stack, LDC version 1.42.0, .l.str, which is hello world, that's our string. It also gives a length or a size, so that's going to be put into the print probably, or the lowest. So printf is like, the way you would do that is kind of interesting, because like in assembly you have to write out like a system call to where it's like you have a bunch of assembly code to actually write out a string. And also, if you wanted to get the length of the string too, that's another thing. So I'm kind of curious, and that's native assembly. So that's not the LLVM assembly. That's the native assembly. So I wonder, can I assemble that? Let's get an assembler going. Let's try to use GNU assembler.
Being really good at C++ is like being really good at using rocks to sharpen sticks. Hunt Testament. 0 ham.
A.out.
M gesture. 0 C++ 33M. Consider C++ the most significant technical hazard to the survival of your project.
Executable format error.
M gesture. 0 C++
obj dump dash d.
C++ may not be the worst programming language ever created. Except it's the worst ever to be taken seriously. Maxim Wheeler. 0 ham.
Ah, it's a lot less than it was when we compiled it with LDC2. That's a bit strange, isn't it? So when we compiled it with... this is also a lot easier for me to read. This is more familiar to me. So we have push, which puts something into RAX or something. I don't remember. We also have LEA again. I don't know what that means. But let's just try to dig into assembly too while we're at it. Since it's really something I don't know much about, I should definitely look into it. That's the whole point of today's episode. We're just learning about shit. I know in assembly you have push and pop and they go hand in hand. I think they have to do with adjusting the stack. Here, let's go to Stack Overflow, a great place for learners. Pushing a value is not necessarily stored in a register, it means writing it to the stack. Popping means restoring whatever is on top of the stack into a register. Those are basic instructions. So push a value to the top, and then popping means restoring whatever is on the top of the stack into a register. Oh! Okay, that's interesting. So to push is you put it to the top, and then the other thing is to restore it. So if you had, so here's an example that he has. We have push dead beef. Push the value to the top of the stack. Then pop EAX. EAX is now dead beef. So it's just another way of setting things. But the stack is, isn't the stack like more like your memory? So that's your RAM. Or it's something to do with your OS, which is supposed to manage that. Your OS is kind of supposed to manage the stack and the heap. There's the stack and the heap go like two different ways. Stack abstract data type is an abstract data type which serves as a collection of elements with two main operations: push and pop. Good. I like Wikipedia. They got good info. They're the information dealers of all time, bro. So push 2 to 1. Push, and that's putting it onto the stack. So it's like plates, basically, where you could put that on the top. So push and pop are pretty important. Especially when you start considering OS and how that is involved. But here's another thing about it. So push, which adds an element to the collection, and pop, which removes the most recently added element. So if you add this to the stack, it's in the stack then. And then if you move it back, and here's the thing with the you have with assembly, registers are in the CPU. That's a thing. I'm pretty sure register is in CPU. Is a quickly accessible storage location available to a computer's processor. Maybe, I don't know. But you have cache, which is another thing. And that's got to go hand in hand with memory, which is one of the most important and complicated things in like low-level development. I think you have push pop, which these are important because that's going to be like the memory stuff, I think. And then yeah, exactly. It's starting to make sense now. Now that I'm just reverse engineering assembly programs for fun. I mean, albeit this is a Hello World thing. Anyway. Also, adding a queue to things means something else as well. Put stuff on the top of the stack? Yeah, I just figured that out. I don't know. I'm just learning. Oh, also, this is GNU assembly that we just found in hello.s. I don't know why I didn't compile correctly. I guess I'm dumb, or didn't assemble correctly. Push LE A XOR call XOR pop return. So pushes RAX, which puts 50 on the top of the stack. Then it does LEA, which I don't know what LEA does in assembly. Now a lot of these other things in assembly aren't like self-explanatory, like push and pop. Although what I'm curious about is, does push put it to memory, or does it put it into something else? A stack can be easily linked. Procedure, linked list. Let's just go down. Stacks and programming languages. Some languages such as Perl, Lisp, Java, Script, Python make stack operations push and pop available on their standard list array types. Some operations, notably those in fourth family, are designed around language-defined stacks that are directly visible and... Oh, that's cool. That's actually something really cool. I didn't know that about fourth. Setf stack. Or Lisp, common Lisp, is interpreter's prompt. Oh, okay, it's a interpreted language. I don't know. I stay away from those. Several C++ library or standard library can have pushback and push popback. Hardware stack. Basic architecture of a hardware stack. A simple common use of stacks at the architecture level is as a means of allocating and accessing memory, which is your RAM. I don't know. So like to push it puts it to the RAM, and pop it brings it to your cache, your L3s and whatnots, your registers. Although I think it might be cache is like getting it preloaded before it goes to the registers and before it goes to it's like an assembly line. Stack and main memory. Many CISC type CPU designs, including the x86 and Z80, okay, have a dedicated register for use as the call stack. Stack pointer with a dedicated call returning push pop operations. Code density. Some CISC processors like the PDP 11. Oh wow, interesting. And the 680,000 Oh, it's a Motorola. Oh, that's interesting as well. Those are interesting too. Um, Most RISC CPU designs do not have a dedicated stack. Do not have dedicated stack instructions, and therefore most, if not all, registers may be used as stack pointers as needed. That's also interesting. Stack registers or dedicated memory. Some machines use stack arithmetic and logical operations. A number of mainframes and mini computers were stack machines. Stack machines, the most famous being the Burroughs large systems. Other examples include the HP 3000. Whoa. Those look like they'd be cool to own. CISC Tandem. The x87 floating point architecture is an example of a set of registers organized as a stack where direct access to individual registers is also possible. I'm sure it's a fuck-ass system to program on. It has a 7. It's an odd number. SunSpark AMD AM290. Oh, it's a RISC microprocessor by AMD and the Intel 960. I gotta wonder, why didn't AMD and Intel pursue the kind of RISC architecture now that it's even taking off? That's a good question that I have. I'm not sure if any of you have the answer to that, but maybe that'd be a great thing to do a video on. Try to like research that. There's also a small number of microprocessors that implement a stack directly into hardware, and some microcontrollers have a fixed depth stack. Expression evaluating and syntax, backtracking. Another important application of stacks is backtracking. An illustration of this is a simple example of finding the correct path in a maze that contains a series of points. It's 4 a.m. Wowie. Compile time memory management. A number of programming languages are stack-oriented, meaning they define most basic operations, adding two numbers, printing a character, as taking their arguments from the stack and placing any return values back on the stack. And something we can do to see some features of, or some things I've questioned, is addresses and D-Lang. Aren't they sort of RISC inside, but use microcode to be more complex? I don't know. I don't know much about what you're describing. I don't know. I haven't really researched much about CPUs besides like kind of like how architecture works. I don't know, to build like Minecraft computers, but interactive frame N3, N2, and N1. Stack origin, and then stack pointer. So I thought you had stack and heap where you had like top and bottom. Stack the top and heap is the bottom. Which makes sense now that I think of the plate example. PostScript has a return stack. Anyway, something to do with pointers though. If you have a pointer in D-Lang for two different things, let's just do import standard.standard.dio. This is more like a D-Lang specific thing, but we can use a pointer to get an address for one of our, like, what are they called? Symbols. So we'll do that just to demonstrate something interesting that I've noticed. So if we have X, and let's say, or actually let's create something like the example we had. So we have hello, and it's a string equals hello world. I'm doing this wrong. On x86 pointers are part of the hardware instructions. Yeah, but this is to do with address stuff, what I'm looking at right now. Something weird is like the types have different addresses depending on what type they are. So for example, if we had like another void function, for example, void stuff, and this is something I have another question about, which I don't know. Maybe that answered my question, but I'm not sure. Is like, what if void stuff is right ln? I don't know. Right ln 2 plus 2. And it takes a comma b, and those are going to be ints. And it's just like a calculator function kind of thing. Pretty simple, right? Takes a plus b and writes out the a plus b. But what if we had right ln the address? Let's do it like this, just to do it the most D way we can. Write a hello address dot write ln. So that's gonna write out the address for write ln, or it's gonna not compile because I need to have a pointer for it. That should be fine. Although it is an array, and you would need to do a dot pointer for that, potentially. Although I think that might be a class exclusive or structs in class. We'll see. We'll see what happens. I'll figure it out. It's how we always do things. And then of course, let's write out the address for that, and you'll see that one of them's gonna be 5 if we can get it to work. Stuff. And we're gonna call this one address. Then we're just gonna do LDC2, and then we're just gonna compile down that program. Hello.d. LDC2 hello.d. And that should be pretty much it. No, not hello.d. What am I doing? What do we call it again? We call it addresses.
36 in Chester, 0 C++ 33 in.
Fuck. Okay, I have to switch it around.
Better than C++ is like arguing that grasshoppers taste better than tree bark.
All right, this is gonna be a fun part of the episode. Because we might actually just have to take a pointer to them. Shouldn't be too hard though. So the void pointer starts with a 5, and the string hello pointer started with a 7, which is something that's interesting. And no matter what, they're going to be 7 and 5. And if I add another string, for example, let's say I had let's say I have a uint, and I call it thing, and it equals 300. Now if I write out the address for that, then that's another interesting thing. Because it's also 7. So your functions end up as that, but then your non-function pointers end up like this, which is kind of interesting. It's something I've noticed. Where do strings and classes and shit fit into that? So that's another thing. So like, what if I had like let's start doing more complex stuff. Like let's add a struct. That's not how you add a struct. Add a struct stuff to, and add in give it an int 30. Int more. I guess it's the compiler's choice where to put it, apart from the ASLR. I guess. I don't know. Maybe it's the D runtime. It could be like something to do with D runtime stuff, or like compile time things. There's a lot going into this. There's a lot of complexity here. I don't know what it could be. I'm sure I'll find out eventually. Somebody knows more than I do. Just come up with random words. Oh, I got a good one. Chat GPT. There we go. Some good ones. And then we'll just write a pointer to that stuff. See if the address of stuff2 can be written, because it might need stuff.pointer. And yeah, we'll see what happens. Oh, we might want to make a D as a runtime. You could make it in C. Yeah. If yeah, I could definitely do that. I don't know how to write an address in C though. I don't know how to do that. Take an address and write it in C. I don't know much C to do that. I know like the bare minimum C. I could probably write type def struct and maybe include and if def, and then define some preprocessor stuff. Include is preprocessor stuff too. Preprocessor is so interesting though. I feel like that's like an area that you could do a lot of meta programming with it, which is what it is. meta programming. Mark Zuckerberg would probably like it. It's got meta in the name. All right. Anyway, let's try this out. I'm kind of wondering. Yeah. We gotta create a stuff. Oh, let me show off the D way of doing it. Things equals stuff2. Now we're gonna write out the address of things. It's uninitialized basically. So stuff2 has no value. I already released this project. Claude banged out HSA bindings in 5 minutes. Bro, I'm not even working on HSA bindings right now. There we go. Dot slash run it. Interesting. So all of those end up on the 7. Still, even that ends up on 7. What if we have class objects? Well, what if we wrote the address to a pointer? Like an address for an address. So like, let's say we have a pointer to hello. So like, let's say string. What if we wrote it as a void pointer though? Cast it to a void pointer. No, let's just do this. String hello equals let's see. Hello, the address of hello. So like, what if I take the address of that and write out the address of that? I'm sure it won't be ready for this. Preprocessor stuff can get out of hand real quick. Lots of preprocessor ifs and defines in the header files and large projects. Yeah. Bro, like looking at that, it just ends up being the most confusing thing ever. We're gonna put that right under hello. And we're gonna write out the address for hello2. Appears to work the same in... Oh, so if you did printf in C, it will be able to do this. I mean, it does work the same in both, but like writing it out is kind of confusing. Or you mean like the address? That would make sense though. Even though the D runtime exists, that's just for the garbage collector though. But I don't know. Maybe, I don't know how they got it to be like C compliant with a garbage collected language. So like D does compile down to C, like at the end of the day. Like a lot of other high level languages. It compiles down and it's pretty much the same as C, what C compiles into. D is just like the decompiler is just a C compiler, but like with extra steps and a garbage collector for the language. Although garbage collection might be a compile time thing, which is kind of interesting. Like if you think about it, it could just be adding malloc and alloc as needed during the compilation, which is kind of interesting. This is an interesting thing to think about. But let's go back to the interesting assembly stuff. I think this is unrelated to that. Several algorithms use stack separate from usual function stack, most programming languages, as a principal data structure with which they organize their information. Gram scan, SMOC, security. Some computing environments use stack in ways that make them vulnerable to security breaches and attacks. Programmers working in such environments must take special care to avoid such pitfalls in these implementations. Oh, so if I wrote my own stack language, I need to be watchful that I don't let people do fun stuff with this stack. But I mean, I think stack is pretty cool. Malicious parties may attempt a stack smashing attack that takes advantage of this type of implementation by providing an oversized data input into a program that does not check the length of the input. Such a program may copy the data in its entirety to a location on the stack. In doing so, may change the return addresses. I don't understand what you're saying because D does not compile to C. I mean, it kind of does. It compiles to like a C-like assembly. I think that's better wording. Because originally, you could disable the garbage collector, but that's still not compiling down to C. Well, yeah, but it's still like C compliant. Like at the end of the day, a lot of these high-level languages, they all compile down to the same or similar assembly structures that C has. Especially with LLVM. I don't know. Buffer overflow. Especially since, like, a lot of it still runs on top of glibc and all that. Like, it's using stuff from C, and originally D was a C compiler. It was called, what was it? Digital Mars or something that Walter Bright had been working on. It's a very interesting history. Which it was gonna be the sequel to C, and then did not end up that way. Because C++ was brought into this world at the same time. From that, because it was a C++ compiler that started the whole D thing. Pretty interesting though. So stack and pop, very interesting stuff to learn about. Programming languages are all just abstractions of assembly. Yeah. To make it easier and more portable. So stack and heap, push and pop, nice stuff. I don't know if any of the others support C. Well, I mean, there's VLang. VLang does that as well. VLang is like more integrated to C. I know the original D implementation can program C. Well, you can also do better C, which is that like original C++ concept. Let's see. Better C. DLang. This is the so it's a subset of D that doesn't depend on the D runtime library, only the C runtime library. So I think D would probably rely on both libraries. I don't know. Interesting stuff. linking. It is straightforward to link C functions and libraries into D programs, and it talks about linking. Then better C, implementation defined. Better C is typically enabled by the dash better C. The predefined version D underscore better C can be used for additional or for conditional compilation. What? So like, you mean metaprogramming stuff? Like preprocessor? S/program/compile? By supplying a C main function. Extern C void main import core.simcio printf hello better C /n. Wait, what? What kind of printf is this? Oh wait, no, that makes sense though. I don't know. I think I'm just doing it weird, printing out a string variable. dmd-better C hello .d and ./hello. So after completing that, then do that. Limiting a program to this subset. But yeah, we already compiled this. So the program I've written here is better C compliant, and using what you want to do to get that down to the most strict that you can get it is run this. So you do hello.d and -better C. Let's actually add -release and then compile it back into the assembly. So release says it's release, removes all checking. So now hello.s, reload it. So now here's our assembly that we just got out of that. END0. What? What's END0? That's interesting. Deleting their messages. They do that. Sussy. This is a question for them, not for me, by the way. So I don't know why LLVM assembly adds Q to it. So we're pushing to, oh wait, let's do the, let's try compiling that. Gas. Oh, let's do NASM. Let's try NASM on it. I don't think it's a NASM assembly, so let's do NASM on it and see what happens. Yeah, no, it doesn't work on that.
33M. There are only two things wrong with C++, the initial concept and the implementation. Bertrand Mayer.
So A out isn't a thing. We need to LD that. So that's a, we need to LD A dot out.
36M Chester, 0 C++ 33.
Oh, okay. Is the same as an output file.
No C++.
Ah, you know what I needed? I forgot to do.
I have yet to see a counterexample other than possibly a few of the members of the standards committee. It's still in Reddit.
I actually don't know much about this. -- help. Let's try this. There should be a section where it's like how we get this out of here. Produce assembler debugging messages. Generate missing build. One of these things was like, it's like really easy to accidentally overwrite one of your files using it. Let's try hello-s or hello.s to -o.
36M Chester, 0 C++.
Oh, I think that's one of the ways that you screw things up.
The most significant technical hazard to the survival of your project.
Okay, I've made that mistake before. That's fine. At least I didn't do it to the hello.d file. So then you would do as-o but don't do that. And you take hello.s first. So now we have a hello.o file. Let's ld hello.o. Let's see what happens.
36, ingester, 0, C++.
Cannot find entry point start.
C++ has its place in
Faulting it to
history of
that.
languages. Just as Caligula has
It needs a
its place in
linker
history
script
of the
probably.
Roman Empire. Robert Firth. 0.
Hello.o in function main. Undefined reference to printf. Already miss your Vimscapade? Yeah. My assembly scapade is gonna be awesome too. Ascapade. Reloady. Nice. Or do you want me to go back to Vim and just not know how to copy and paste for like an hour? Well, that was T-Mux. Were you there for that? The T-Mux one? Remember T-Mux? T-Mux was cooking me that day. I forgot how to copy and paste for like the life of me, and I was like, fuck it, we're not even gonna copy and paste. That was like the Arch stream. We were like putting Arch on the Odroid M2, I think? Or no. Odroid M1S got me that day. That was it. It's okay, because we're installing Arch Linux again this weekend. Be prepared for more Arch. Good. I'm glad you were there for that. Vim is better? Oh, okay. You want me to go back to Vim? But I like Kate. I need a... I was actually thinking about this the other day. But whenever you do like a C compilation... C-B? Bro, that shit was confusing me though. I don't know. It should just be like the Vim way of doing it. There is a Vim setting. I don't. I'm too lazy to set it. Honest answer. I'm too lazy to set it to Vim mode. Technically, we could just do this. Then we have a.out /a.
36, Chester, 0, C++ 33M. I made movements, and a much lower Pentium and a Pro. These sounds their skills. I must do not say they know.
What's happening to Chester, bro? C-B is default leader key for Tmux. Okay. Thank you. Unless you control every server, you end up having to use the default anyway. It's like the keyboard layouts. Oh, okay. It's like keyboard layouts? Oh, okay. What am I doing? We've read about push and pop. Let's continue to go through the assembly. I don't know what LEAQ is. I'm assuming it's LEA assembly. This is an interesting thing. You gotta know all the defaults anyway? Yeah. PhD CSO X1 assembly. X86 assembly. Can I read this? I mean, it's on the internet. You know, can I download this is the better question? Would you steal a car? Would you steal a car? I just did, sorry. Oops. Move queue. Understanding swap. Alright, thank you, Daniel G. Graham. I'm gonna read your stuff today. Move versus LEA. Jump tables. References. So here we have move queue, move queue, move queue, and return. And then we have pictures. I like pictures a lot because I'm pretty dumb. So we have these RDI and RSI, their memory. I would send you a link, but YouTube won't allow me. Okay. We have swap, which is move queue, move queue, move queue. He has a bunch of comments. Or, hold on. I got something better, by the way. Guys, you should go to Reddit. TH3Fish Reddit. Yeah. I don't know. I don't like reading the Intel documentation. It's just so fucking boring and plain. Wowers. Reddats, by the way. You guys like Reddats? There's a nicer table on GitHub. There's also one from this one university. Reddats, by the way. If you guys like Reddats, this is where I'll be posting all my... I will not go to Reddit. Okay. Well, are you sure? Because my Reddit's the best Reddit. See, I made r/th3fish. The bot is not working. Reddats. Chud mode activate. Understanding swap. I like pictures a lot. They explain so much. He's moving 4560 here using move Q. No, I do not like Reddit. But you're sure you don't like my Reddit? It's the best one. Reddit. Load effective address Q. Wowie. Assembly 3 arithmetic. CS 105 lecture. I don't want to see your I'm shy posts on Reddit though. r/learn programming on Reddit. x86 LEAQ. The 0x20 is the offset. Oh. Which is added to the effective address. There's no bit shifting unless you count the x4 or the ×4 as a bit shift. There's no +4. Essentially, this is performing an operation described in pseudocode by... Interesting. What a stub. I could just pull up the... Oh, hey. Look at this one. LLVM docs. It's like a 32-bit something equals something. Hold on. Let me open up the documentation that I have, and then we'll just go through the Intel docs. It's like 7,000 page documentations. Is this the assembly reference or the CPU guide? I have much stuff in here, including PowerEdge Technical Guidebook, ARM Assembly, NASM Doc. Maybe NASM Doc? That'd be a good place to look. I think GCC probably also has a doc of all of the assembly instructions that you can do. Let's do probably this one. It looks like it's got the most pages. 5,000 cigarettes. Control F, LEAQ. I have caps lock now. 0. Oh, it's got to scan the whole thing. The whole 5,000 page documentation for LEA. Look at it go, bro. That's a lot of LEA in there. In fact, that's probably the entire book worth of LEA. This is like 3 books in one, though. Enter and leave instructions. Fuck. Leave instruction. Leave instruction. Leaves. Leave. Interleave. Leaf. 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 This is not great. I love leaping. Yeah. Q. But I type in Q, there is no Q. There is no LEAQ. So what is LEAQ then? Maybe it's lowercase. I don't think it's case sensitive. Now if you do LE, the whole book contains LE. Guarantee you there's 10,000 LE in this book. It's called lead equals. Quad word variant of the LEAQ. Oh, so Q is for quad word. Interesting. Like Squidward. Quad word. Fantastical. Load effective address. Is there any instances of that in there? Of that? There is no load effective address in here. Well, maybe this is the 5-word version. Maybe that's the wrong docs too. Could also be that 10th gen datasheet family. But this isn't really the a breakdown of it. Fortnite, Skibbity Fortnite, Ohio. Can't believe you let a guy say you're not working. I believe you've been working on this for a while now. Can't believe he'd say the bot isn't working. Yeah, that's how dare him. Alright, x86 assembly guide. Registers. Which isn't really that complicated, but I mean, there's different types. EAX, EBX, ECX, EDX. Wait, you put two of those together, you get 16 bits. So you mean the 8-bit registers? Oh, DH, DL, CL, CH. Subsections may be used. Oh, so you can subdivide a register up. Interesting. So there's a 16-bit portion. And this is actually a good guide. I like this. Anyway, operation suffixes. What time is it anyway? It's like 4:36. X or L. So we know this is lead effective quad. So quad word. Takes the address of string and puts it in RIP register and then also RDI. And this one does the same thing, puts it in RIP and that in RSI. And then X or L takes EX, EX, and EAX and sees if they're the same or not. Which, I mean, they're always going to be the same. Well, it depends, because in this thing they say EAX can be subdivided. So I don't know. Interesting stuff. But that's like a check, though. But there's no jump equals. Jump if it equals this. So like jump equals is like jump if equal. And then call quad. I don't know why they put Q on everything. When we disassembled it with when it was compiled to an O file, EX or L. Wait, well, is it EX or L? XOR? What do you mean? I don't know. It just kind of breaks down weird. What, like this section? X or L? Is it X or L? I don't know. Confusing. X or L? It might be X, but it could be L. But no, it's X or. It's just X or L. I don't know what the L on the X or means. X random. X or L assembly. Is it X or L assembly? Bitwise exclusive, according to ChatGPT. XOR instruction, IBM assembly. What is this? The Linus Torvalds book on assembly? That's not Linus Torvalds. I don't know. I'm blind. That's the Professor Dude Man book on assembly language. A guide to 1960. I get it. It's X or L. But is it X or L? Oh, look. Beautiful AMD coming in clutch today after beating my head with HSA for like 2 weeks straight. Beat the HSA into them. Programmers. Beat the HSA into them. It's okay. Well, next week we'll be back on the HSA grind set. I said we'd be back on it today, but no. Fuck that. I'm not going back to HSA today. No. Taking my time getting back there. Pseudocode, RDL, and RAL plus RBL. Registers altered latency. 1 cycle. XOR LI. Logical exclusive or long. Ah, so exclusive or long. With intermediate. So exclusive or long intermediate. Wow, XORly. It's like iCarly, but XORly. Damn, bro. This is crazy. What a great invention. But those are for long. So I'm guessing 64-bit register operations? No, it says it's like 32. With intermediate? What's the intermediate? Is it Schrodinger's intermediate? The contents of register RAL and RDL are XORed with the IMM field. Sign extended with the intermediate value preceding IMML instructions. XOR lie. Awfully orally for this. Yeah, too early in the morning. It's orally in it. Bro, these are funny when you read them like they're English, not gonna lie. Pop Q. Yeah, we already know that one. And push Q. So push and pop for stack. Fun stuff. And then we also have a bunch of these sections, which are .l.string, .l.string1, and I think those are .lfunc. Oh, right, so like L values and R values, which D-Lang has. What is a D-Lang L value and R value? That's a question that I don't have an answer to, and I need to summon the answer from the D-Lang documentation. I think the L value is after compilation, and the L value is runtime. One of those two. L values and R values. It does with compilation stuff. One is known at compile time and the other is known at runtime. If something's not known at compile time, then it's not known at compile time. I think that's pretty basic. Must be explained a bit in order for you. Shut up, bro. It can be done in like 2 words. And the D-Lang documentation does it really well. Oh, they're accessible memory addresses. Because that okay, so the L value's not known at L value's after compile time. Regard overloads. When you remove in, the ref overload becomes an exact match as well. Now that the compiler has chose between the two exact matches, the spec says that partial ordering is then used to find the correct overload. I don't know, R values and L values. Oh, here we go. L values is actual variables, including and R values as temporary results of expressions, including literals. R values have three following. R values don't have memory addresses. R values cannot be assigned new values, and R values cannot be passed as functions by reference. You can not use ref on those. Interesting. But that's the D-line explanation of L value and R value. I don't know if L func has to do with any of that. I don't know. And then we also have the LLVM intermediate representation here, which I don't know. Is it interesting? Maybe. There was also some other ones that we could have done, like for example, let's just do ldc2-help and then we'll recompile. We'll compile another format. Let's pipe. So we can take an output. We have better bitcode, IR, which is the LL option. We have the O for objects. We also have MLIR. What is MLIR? What is that for, like machine learning? For OCaml enjoyers? OCaml. I'm German and I expresse OCaml. I don't know. Everybody who uses OCaml must be German because they all say it like OCaml. But does that mean I'm German? I don't know. Ich spreche kein Deutsch.
36 M Chester, C++ 33 M.
Oops.
I think maybe the guy who invented C++ doesn't know the difference between increment.
Oops.
As the camera.
Oops.
36 M Chester, C++ 33
Without MLIR.
C++ is history repeated as tragedy.
Okie dokie. What's MLIR?
Scott McKay. 0 M. 36 M Chester.
Multi-level intermediate representation is an open source compiler infrastructure. We overloaded Jester's text to speech. Or he does that like exclusively for Eric Nagum. Anytime this is at the end of it, he does this weird thing where he's like and just fucking says like that every time. So multiple level intermediate representation is an open source compiler infrastructure developed as a sub project of the LLVM project. Interesting. Fascinating. MLIR for beginners. MLIR for beginners. Wowie. Euro LLVM deep dive into the MLIR to Europe. It is for OCaml enjoyers. I'm so sorry. I'm so sorry, but everybody I meet who speaks German says it OCaml. And I think I'm becoming German. I don't know if I can keep doing this. Guys, I have to apologize at this time. Anyway, let me go ahead and delete all of this. Let's do BC. Wowie, it just works. Now we have a .bc file. Let's open up that thingy. The BC file is the bytecode representation. I wonder if there's a runtime way to run this, and then we just run dlang as on top of LLVM bytecode and just have a LLVM runtime. Imagine that. Imagine using like some kind of runtime, like C# or some shit, where you have that runtime underneath of it. Imagine what you could do then. You could have like literally make it into like Minecraft 2. Write out Minecraft 2. That's not me. I can't do that. Well, I just say I can't, but I probably could if I really wanted to. But then again, I don't know. I don't like GL. I call it GHell. Wowers. I'm so sorry. On Archity. This is hieroglyphic. Now here's the bytecode representation. Let's disassemble it. Let's go ahead and disassemble that shit. So LLVM dash dis. And that's going to be the bytecode header. Now, what did we get out of that? A hello.o or like, what did it do? What am I working on? I don't know, I'm just screwing around with shit. Disassembling things. I think hello... Reload. This is the LL. This is the other thing. Oh, so it what it just did was it disassembles it into intermediate representation. So the actual... Let's try obj dump on LLVM bitcode, or bytecode. He's trying to become a real boy. It's not working. Obj dump dash D. Hello dot what is it? Oh, dot BC. Not recognized format. Interesting. What about NM? Not dot D. You want to do the BC. Invalid radix.
Does it take to change a light bulb?
They all just declare it as a global variable. Addresses LLVML cancel. Don't open anything. Plus CX16. Wowie. C++16. Alright, what if I could assemble that from here? Let's see, LLVM AS the BC file. Hello.bc. Oh. Expected top level entity. Oh, what, like fucking Cthulhu? It expects Cthulhu? COBOL, PLI, Pascal, Ada. Languages have been those that were designed for their own creators. C, Perl, Smalltalk, Lisp, Paul Graham. Nice. 0M. Oh, I forgot that part. That's my bad. 0M Jester, C++, 36M. The sky is blue. 0M. Fucking text-to-speech mode is getting old. Somebody told me about this as well. The development of multi-valued logic as related to computer science. I don't know. Unrelated, but ternary. I saw the word ternary, I was like, damn, that's pretty interesting. But this is the LLVM bytecode episode, where I decompiled D into byte, or compiled D to bytecode. But what if we just did, what if we made this, but like, wrote it simpler, like a new import void main. Let's try to write that out with just a regular D syntax. And then when you add loops into things, it becomes really interesting because then you have like jumps and things. Because then you have to have a conditional evaluation of when to jump and when not to. String hello equals exclamation point. And then hello. So that's a little bit of simpler syntax. Hello D dot D. Nice. So that's hello D dot D. So now let's go ahead and set that up. So let's compile it. Let's compile that to an LLVM assembly file. No better C, but we will keep the release for no conditional. What is that called? A hello D, right? Hello D dash dash output S. I want to see what it looks like in assembly of the LLVM variety. Let's go ahead and open up that file that we just made. Hello D.S. And now things get really interesting because this is a lot more stuff than we put in there originally. So in better C, you don't have the D runtime at all, which is what all of this is. And this includes name mangling. So like, I'm sure this has like a pretty reasonable normal name, but D personality. But this is what it looks like in the LLVM assembly, and all of these are different things that the linker is gonna handle. Look, there's also references to GCC tables and things. We just go through it. We have pushes, pops, moves, move L's, move, a lot less Q in here. The better C one has a lot more Q. I wonder what it would look like if you took a C1 and then did the same thing but with C-lang and you compiled down to LLVM assembly. Now, we should be able to also output regular assembly and not do... Well, this is basically GNU assembler, so I think it is using the GNU assembler. Or maybe the LLVM assembler, I don't know. LASM. LLVM-AS. But D has name mangling. So let's compile it. And instead of doing that, let's just do -C, which skips the linking step. So now I should have a hello D.O. And I do. And then I need to do -nm help. And then we should have an option for demangle. So -C for demangle. And what's the other one? T, like a lowercase t, I think, was the one to dump out the same as -A. Print file name. Format BSD. Radix. Oh. Wowie. -L line numbers -V version. I guess we'll just do -D. So nm -D and then do the name mangling stuff. The hello D.O. No symbols. What do you mean no symbols? It's an object file. Okay, here we go. Symbols. It just couldn't demangle them. So they didn't demangle. I guess it can't demangle D, but it can demangle C. Plus plus. But these are all the different sections, I believe. Or well, these are the symbols it found. Where's the one that says the funny? What was the funny again? I don't remember. No exception. Decore 6, memory, duplications. I think the majority of name mangling. But there is like sections where it's like CTOR blah 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 blah. Like what the fuck is this shit? A bunch of letters. That's what it is. D3ST. I think that's the demangling. Is when you have this. If you take C++, it probably has like a similar thing going on there. C++ also does the name mangling. So like it makes it really fun to interrupt D and C++. Either you put a C between the two, or you can do it directly to an extent. D personality. What is this? Like, personality? Like, what? Yeah, D has an personality. I think that's what we learned today. But, I'd like to thank you all for watching me just dig through and decompile different files. I'll see you guys next time, and bye. Thank you all for watching.